types of problems. When it gets into the calculator, non-calculator, we'll start to worry about what it all look like as we get going. But I don't think this is actually unit 11, I think it's 8. But basically what we're looking at is we're choosing a bunch of different function model stuff. And we're going to be looking at either, like I said, linear, quadratic, polynomial, which mean cubics, exponentials, logarithmic, or trig. The material that we're going to cover in the course of the next week or so is going to be really straightforward. You guys have all done this, what we're looking at today, as far as positive, negative correlation from scatter plots. Do you remember what a scatter plot was?
Is that just a bunch of random points and you draw a line through them?
Yeah, and that's kind of what we're looking at. What does a positive scatter plot look like?
It's positive. It goes top, it goes upward,
Thanks.
and rightward.
That's
A smiley face.
they're generally going that way. I agree.
Upward and
So
rightward.
upward and right. So the scatter plot that looks kind of like this. Bunch of data sets going.
That's what I meant to say.
Pretty much. Because that's what we're going to be looking at. We're looking at the positive correlation. It's, does the data set look like that? Does it have that up and to the right look to it? It might not just be a whole slew of dots. It could be just like 4 or 5 of them. But does it have the look of something that's going up and to the right? Basically, does it mirror the slope? Does it have a positive slope? What do you think the negative correlation is going to look like?
Downward and leftward.
Whew. Like I said, there's something.
Well, does it look the same except
Does it look the same except?
it's going down?
Like that.
Wait, is it up and left?
It's going
Down and right.
down and right.
It's always going
Oh,
right.
down and right.
Up and left, down and right. Remember, when you're talking about slopes, your first step was always to go up or down. The next step was always to move to the right. And then obviously the no correlation is something where you couldn't tell whether it's moving up and right or down and right. There's just dots everywhere. It's complete pandemonium. Cats, dogs living together.
What if it's all like curved like a parabola? Still no?
Then it could be, then in this case, it's not going to be linear. It'll be the quadratic. And we'll talk about that tomorrow. Okay? It's a very, might have to actually introduce you guys into a matrix tomorrow to show you how you can pick 3 points and set it up. It's pretty cool. Okay? So like I said, this is really straightforward. Okay?
From point where it.
Now, the other thing I wanted to show you guys is how we're going to be able to take some data set, some scatter plots, and how you can use it to interpret data, to make an assumption, to write an equation, things like that. So it works out well in this class because there's more than 7 guys as opposed to 6th hour. There were 4 guys in it, so it was really tough to. I don't normally use the girls one because a lot of times girls don't like to talk about weight, and I'm just.
Maybe guys are self-conscious.
If you're self-conscious, that's fine.
I'm
I'm not trying to be sexist or anything like that, but I've known, being a little bit older than you, guys normally don't care. If they do, that's fine, but normally don't. Girls tend to more care about it.
Let's just get, we can just do it, guys.
And I'm not, I'm not.
I want to do this problem with sex.
Would you like me to change it to shoes?
There's 7 shoes in the class.
Oh no, you talk about the size of your foot to your height instead of weight. We're the same idea.
Where's the issue? That means someone doesn't have shoes.
Continue with what we had planned.
So I have like 7 gentlemen here. How tall are you? Fine, you can be the first one. How tall are you?
6'1 1/4.
I'm in a car.
So inches.
73.
Okay.
145.
Okay.
That's close to that. One.
I think like 70 inches.
All right. You don't know how much you weigh. You're not on the
God
table.
dang it, Allie.
Dylan,
67 inches and 120.
Zach, what do you got?
71 inches and 135.
Alright, I'm figuring out how tall I am.
Zach, you multiply by 12 and add the inches. Look at what you got.
69 inches. Much is it? 180.
What are you asking? Lincoln.
69 and 155.
Okay.
64 to 120.
177 centimeters and 80 kilograms.
Get out of my class.
What did he say?
What did he
He
say?
didn't.
He said in the metric. He doesn't like the metric. Alright, Liam, get this.
Now we just have to get rid of me and the classroom will finally be okay.
Oh, you got rid of the turkey.
You gotta open the door for him. You gotta open the
70
door
and
for him.
134.
Roll it back in until you get to the
You put a
American.
4 after we have all zeros and 5s. You're 135. You gained a pound. Congratulations. You had a Twinkie for lunch.
Roll it back in until you said
All right. Now, at this time, besides just I like a bunch of dopes, we have some data set. I just picked it because it's just getting cleaner and making breaks. That's all. Does it matter which one you choose for X's and Y's? No. This is our first column. Let's call these our X's, and these are going to be our Y's. So we're going to create a graph out of it, and we're going to plot like it's basically a scatter plot. Okay. Now, when you're setting these things up, do you have to start at 0 and mark off all your tick marks? Nope, not at all. In a case like this, what I'm looking at, knowing that my, what do we say, height, and this is our weight. No, I was trying to write. Somebody else could have helped her out.
No one else here likes me. No one else.
And I'm sorry about that. It's a shame because you're a nice person.
At least I always remember her name.
Okay?
Do you want this or can I just?
You can throw it back there. Thanks. So you wind up with up with the weight on the Y, height.
I'm sorry. I don't know why I went that way.
Our shortest person in this table was at 64 inches. So what I'm going to do here is I'm going to go started at 62. And it went all the way up to 73. So I'm going to go 62 to 74 and go by 2s. Is that okay?
Yeah.
4, 6, 8, 72. You can fluctuate it however you want. In 6 hours, since we had a wide range of heights, we wound up going by 3. It's just because it worked out a little bit cleaner, just to visualize it out. Weights, we started at a $120, and we went all the way up to 180. So I'm just going to go by 10s. 20, 30, 40, 50, 60, 70, 80. Look, I can count by 10s. And a lot of times, students just have the hardest time just putting that part on there.
Yeah, that's so hard.
Well, it shouldn't be, because all you have to do is look at what you're starting with and just go.
Well, it's hard because sometimes you don't know how to scale it. I struggle with this in biology.
That's okay. Hopefully, when you do a couple more of these, you'll get better at it, and that's the whole idea, okay? Now I just plot them through. So we're at 73 and 145. Oh, correct the 74 here. 73 and 145-ish. 67, 120. 71, 135. 69 at 180. 69 at 135. 64, 120. And 70 135. We okay with that? That's a scatter plot. Just things thrown up on a graph. Not like literally thrown up on a graph, but things placed on a graph.
Do the opposite if people got lighter as they get taller, right?
It would be the opposite.
Of this, it'd be.
Yes, this one, as you look at it, do you see how this kind of comes in the idea of it being a positive correlation where things are increasing with height? So what you do is then, we're going to try and come up with our line of best fit. What I want to do is try to draw a line through that kind of mirrors out the best way I can run into a couple of these ordered pairs. I don't want to sit there and move it all the way up here. So I did this. It's too steep of a rise. The data looks like it's rising through here. So you're kind of picking out an idea of what the best fit might be. Now, everybody's best fit might be a little bit different. Especially depends on how you scaled it. When you put your stuff on the line, it's going to be somewhat difficult sometimes to make sure it lines things through. So what we're going to do is, do you remember how to write the equation of a line given 2 points?
Is it like the n minus x?
It's the point slope
y,
stuff.
n plus
Yes.
x?
But in order to do that, you have to find your,
Y1 and y2.
yeah, pick a point. Pick 2 points. Well, I'll pick this one and this one.
So there's Y1 and Y2.
Yeah. So here's what I'm doing. The first point I chose was what? The 64 and 120? This guy here. And the other one was the 73, 145, I think? I'm going to use those as my ordered pairs to work with. So I'm going to not look at my graph right now. I'm going to go back to a single page. Slope is the change in y over change in x. Do you agree? Okay. Now, if I'm looking at these 2 points, my y value is 145 to 120. What's the change?
25 pounds.
25. So my numerator is 25. And the height was what? 9.
9.
So my slope is 25 over 9. It's kind of crummy, but it works.
Wait, they're happy?
I can't take I'm not taking the square root, I'm just finding the slope. This doesn't simplify. What can you divide 25 by? 1, 5, and 25. What can you divide by 9? Oh, no. What's happening here, it's not the same ratio. What you're thinking of is when you did the ratios of the areas versus ratios of sides in geometry. Okay.
It's the geometric ratio.
So you have y minus y sub 1 is your slope times x minus x sub 1. Did you know that was your first introduction to h and k?
Yes. No. I'm just saying it.
Because this is the same thing as saying y equals m x minus h plus k. It's the same thing.
What'd you look at?
Point slope form is your first h and k. You just didn't know it.
It's David.
It's no big deal.
Why did they have us write y1 and x1 then? Just for simplicity's sake?
Yeah. When you're first starting it, yes. So now, does it matter which ordered pair I choose to work with?
No.
Nope. So I'm just going to use the 64 and 120 because I can see that. So I have y minus 120 is our slope, 25 over 9, times x minus 64. Solve for y. Yes, you're going to get crummy fraction, but you have a calculator that works with crummy fractions.
Do I have to bring my calculator?
That would be helpful, yeah.
That would have been nice to know.
Oh, like calculators in the math class?
Well, we haven't needed them in like 3 months.
Where did you get a set?
Where am I getting what?
People actually
You'll
signed
see,
up for that.
so when you set this through, you get 25 over 9 times the negative 64. Oops. Math, enter, and I get a fraction. To do that, I have to add 120. So my equation is 25 over 9x minus 520 over 9. Okay? That's the equation of the line that I'm getting according to my data. Let's check it. I'm 6'3", and I'm 190. So with any luck, if I substitute x and y there, it should be right. So 25 over 9 times 75 minus 520 over 9 says it's 150. What I'm doing is I'm taking this ordered pair, I'm checking to see if it works.
Like, where do you put it in?
Oh, x and y. Here.
Into the 25
Yeah.
9x minus that 20.
Yep. What I'm trying to do is I'm substituting the 75. I'm trying to see if it equals 190.
So you don't put it back into the
No, this is the one. This here is the simplified version of that.
No, the one above.
No. Yes, ma'am. I was just
you.
yeah, that's me. I just picked up one to see how close it was. No, it wasn't very close. Because according to our model, it says that I should weigh 151 pounds.
So does that mean our mom is wrong?
What's that?
You just don't fit our model?
I don't fit your model, yes. Literally and figuratively at this point. What happens here is if you think about it,
Is that what you said?
because I'm not 150 pounds. Yes.
No, figuratively, like your figure.
Oh, I didn't even catch that. Oh, I didn't catch that. That's good. Yeah, I should remember that one. Think about why it didn't work as cleanly by doing it by hand.
We have small, skinny people.
We have small, skinny people. Are you calling me fat? Now, what happens is we have a very small sample size. You guys know what sample size is?
Yeah.
We have a very small group that we're working with, and the fact that when we scaled it, it doesn't look as clean. Our graph might not have been perfect, but your calculators could also write the equation. Remember how to work with lists on here?
Second statistic.
It's not wrong. What we did wasn't wrong, it was just off. It's not as...
Because we're doing math that you don't have to write.
Ish.
There's going to be a right or wrong answer.
Yeah. This is a right-wrong answer. We did everything correct. I doubt everybody ended their weights in 5s and 0s. I mean, Colin knew you ended in a 4. I said, no, you don't. You had to. So we gave you. So we had
That one is blinking.
yeah, we set you over the edge, right? So what I want to show you guys is how you work with your table scan. Hit the button that says stat. And then I want to automatically right away, it's kind of redundant. I want to hit enter, and I want to change and work with my list. I have L1 and L2. What I'm going to do for L1 is put in the heights that we had. And then in L2, we'll put all those weights. So L1, all you have to do is overwrite, or 73, enter 67, enter. 71, enter. 69, 69. And I get the first data column done. We do the same thing in the other one. Kind of forgot the numbers. 145, 120, 135, 180, 135, 120, and 135. You okay with that?
Yeah.
Hit stat again. Move it over to where it says calculate. And if you look at the options that we have, I want to use option 4, linear regression. Because when we scatter plotted, when we use the scatter plotting, I don't think it's a word, but when we put the scatter plot up, we notice that our data was increasing what seemed to be at a normal rate. Option 4. I think your screen might be different than mine because of the operating system. And hit enter. And that's given us our A and our B. So your slope is 2.9 and your y-intercept is negative 61.53.
Is that from the best possible?
This is the line of best fit, yes. Yeah, this is the line of best fit for what this graph looks like.
That would make the. Is the reason the 61 is negative because if you have the point slope on the left side?
Yeah. So it's just kind of small data set can not give us the best graph. That's all. But yeah, the calculator will do that kind of fun stuff for you. It'll calculate. It'll do all that. So we set our line. So our equation, if I use what the calculator says, y would equal 2.9x minus 61.53. Now if I use that value with the 75 inches to check and see if it's 190, it might be closer.
So when we're doing this at home, do you want both or do you want?
It'll kind of the problem. Oh no, it still says 156. So
You got closer.
I got closer.
You need to put some
So
like.
it's just guess and like.
There's no guess here.
Why is it wrong?
It's not wrong.
It just doesn't fit the
Right.
It's no.
His body type isn't similar
For-
to a bunch of high school sophomores and freshmen.
There you go.
Well said, Blake. Could
All right.
have said that myself.
All right. Who did we use on here? All right. How tall are you?
71.
Okay. Use 71. Check and see if it's your weight. Now you're in high school. You're right. I don't fit the mold because I'm not 15 years old.
Nah.
How close is it?
About.
Butler, you try it.
I have to try somebody from the actual data set.
You don't know how tall you are? Nope.
Yeah. Can I do it or someone else?
Go
do
for
that
it.
thing?
How about we try somebody from the data set?
No, it's just, all we're doing is, what I need you to understand here is you're worrying so much about big picture. We picked 7 people,
Yeah, we only used one. It's like 11 pounds.
okay? We used 11 people, we used 7 people. We used 7,
Why did we use 7? Yeah, this is better.
what the calculator, what we did is we took the data We made a scatter plot of it and took a guess at what the equation would be for that data. No, for all 7 of them. That's all it is. We try to come up with an equation that fits these 7 people. When I check to see my height and weight versus that equation, just to see how close it was. That's all. Hopmore did it and it wasn't close. You guys did it was pretty close. So, well, I don't know. That's all it is. Same idea goes where we try it with, did all this. Do the same thing with the calculator right off the bat here. Lists. You have 4 data sets there. A lot of times they're talking about yards and touchdowns. What we're going to do is try and come up with an equation using just the calculator. What would the equation be for this when it's linear? Because what we can do is use the data to get a rough estimate of how many touchdowns somebody should have after so many yards. Or if somebody scored so many touchdowns, how many yards would they have had over the course of their career? This is the kind of stuff that you can do with these linear setups. These are things you guys have done probably in science. Okay? Probably have. Extrapolating graphs, things like that. Predict those things. On the park test, there were data sets that you guys had to look at graphs of. Well, I know you didn't look at it, but now you just know how to try to set it. Yes.
You have to try this sometime. Do we have to try this time?
Please. Okay.
Is it 2 parts like last time?
I don't know. I really don't.
It just seems so counterintuitive.
Let's see. Stat, edit, list 1.
16, 17, 18, a lot of time writing.
You start from the top and delete several times.
Yeah. 16.7. Thank you.
98.
So now we can go back to stat, calculate. Do you guys get this equation?
Yeah, there we go, 110.
That looks like a dog somewhere.
90, 70.
If you transpose a digit or miss a decimal place, it's very easy just to make a silly mistake. So I'm getting y equals 8.19x minus 26.36 when I'm using my 2 decimal places. Yes, ma'am?
You got it.
For now, yes. Tomorrow will be quadratic. And you're going to be able to start to look at data, and when you scatter plot it, to tell what mold it's going to fit into so that we know what button to press. All right, the process for setting it up is always going to be the same. So now it's a matter of, can you take this equation? Did it work? Did you just miss a decimal?
I forgot to erase a couple of
Oh, yeah. What'll happen then is you can find, you got the equation, but you can take that equation and figure out how many touchdowns did this guy have? How many touchdowns did the Bucks have over the course of his career?
Does the book like take the exact number and like turn it back, or do they just let you assume that's the right?
What do you mean?
Like, are we going to get the exact amount of touchdowns that Jerome Bettis got, or they just make like an equation and just put numbers up there?
It's a minus. Sorry, I just realized that. I knew as soon as you said is that because the cursor's in the way. It's a minus sign between here. The cursor just winds up in a bad spot. X. Now remember, what did you put your yards in the table as?
Thousands.
Thousands. So this should be your X value here is what?
13.7.
Don't forget that, otherwise he's going to have a whole lot more touchdowns. Did you forget that? This is like 8,000.
Wait, is it 13.7? Is that what we put in?
It's quite a few touchdowns.
Do we put in 13,700 or 13.7?
13.7, because remember that when you did the table, it was in thousands. So what did you guys get then? 86-ish, 85, 86, in that neighborhood?
You can't get one touchdown.
Now, can you work backwards? If you knew someone had so many touchdowns, could you figure out how many yards they had? Because the number of touchdowns in this case is what? 105. It was 86 around it. So in this case here, what you're looking at is you can be given the y value, find out x. It's just a matter of making sure you set up the equation. The material here today, guys, is really, really easy. There's really no curveball or anything to it. It's just reading what they're asking you to do and doing it. Okay?
So basically, we're given a list of the homework and we just use the calculator to find the.
A lot of it, unless remember, at some point in time, it wouldn't be a bad idea when you're doing one of the linear ones like these to crank one of them out by hand, because it's not going to be that difficult, because I'll make you do one by hand with the dumb calculator. Yeah?
12,986.
Do those, please.
You're just going back.